to the countdown.
Tahniah! Siaran langsung ini dibawakan khas kepada anda oleh Akademi YouTuber Malaysia. Sebuah inisiatif e-didik Malaysia dan Kelab Guru Malaysia. Tumpukan perhatian anda. Siaran langsung akan bermula sebentar lagi. Link sijil akan diberikan di hujung siaran ini. Pastikan diisi dalam tempoh yang ditetapkan. Terima kasih.
Assalamualaikum dan salam sejahtera semua. Okey, hai para guru, ibu bapa yang dihormati dan para pelajar yang cikgu kasihi sekalian. Okey, selamat datang ke Pusat Tuisyen YouTuber AYU. Okay, usaha sama Malaysia, e-didik Malaysia dan Kelab Guru Malaysia bermula percuma selamanya percuma. Okay, untuk mendapatkan keberkatan kelas kita pada petang ini, okay, mari kita sama-sama mulakan kelas dengan bacaan umum kita Al-Fatihah. Okay, apa khabar para pelajar yang cikgu kasihi semua? Okay, harap semuanya berada dalam keadaan baik, bersedia untuk meneruskan kelas kimia kita pada petang ini. Okay, cikgu percaya pelajar-pelajar dah tak sabar nak ikuti kelas kita. Okay, cikgu perkenalkan diri dulu. Okay, cikgu selaku moderator petang ini, Cikgu Mawar Hanifah Nik Hassan, okay, atau Cikgu Mawar Kimia dari Kuantan Pahang. Okay, hari ini kita ada kelas tuisyen kimia Prayu. Okay, petang ini juga kita bersiaran secara langsung dari channel Teacher Lau Chaiwi, okay, atau Teacher Vivi Lau. Okay, sesiapa yang belum subscribe Teacher Vivi Lau, silalah tekan butang subscribe sebagai tanda sokongan kepada Teacher Vivi Lau. Okey, untuk makluman semua pelajar, nama penuh beliau ialah Teacher Lau Chaiwi dari SMK Tinggi Kelang. Okay, tajuk yang akan disampaikan pada petang ini ialah Intermolecular Forces. Okey, pelajar dan para penonton dialu-alukan untuk mempelajari topik berkenaan. Okey, kelas ini berlangsung lebih kurang 1 jam. Okey, bersama juga cikgu di studio ini ialah kita ada Teacher Tang, yang mengajar kimia matrikulasi dari Kolej Matrikulasi Selangor, sebagai control host. Okey, kita juga ada Cikgu Syahnon, dari Kolej Matrikulasi Pulau Pinang, dan juga tim kimia AYU, iaitu sebagai pemerhati. Dan sebelum kita teruskan kelas kita, cikgu juga nak ingatkan semua pelajar dan penonton yang ingin menghantar komen, akan menggunakan bahasa yang sopan, gambar profil yang bersesuaian. Okey. Juga sila fokus pada isi pelajaran akan disampaikan dan hanya menggunakan ruang chat untuk menjawab soalan, dan jika ada soalan yang hendak diberikan. Okey, untuk AYU code cikgu akan umumkan dalam dua kali, iaitu masa kita rehat nanti dan juga kan. Cikgu percaya semua yang hadir pada petang ini merupakan pelajar-pelajar yang cemerlang. Okey, mari kita tunjukkan disiplin yang baik. Okey, diharapkan semua akan dapat memberikan sepenuh perhatian semasa kelas bersiaran. Okey, tanpa membuang masa lagi, cikgu serahkan kelas kita kepada Teacher Vivi Lau. Silakan.
Good evening, students and teachers. Thank you, Teacher Mawar, as a moderator for today's lesson. Thank you, Cikgu Shannon, as an observer to ensure the smoothness of the class today. And then thank you, Teacher Tang, as a control host for the lesson today. Okay, today I will go to the topic of the molecular forces. Before I begin, let me introduce myself first. So I'm teacher, my name is Lau Chaiwi. I'm currently teaching in Pusat Tingkatan 6 SMK Tinggi Kelang. This is my PU teammate. So we have Maths T and Maths M department. And we have biology, PU biology, and physics, and accounts and economy. And last but not least, chemistry. Okay, so let's begin our lesson. So today we are going to learn about intermolecular forces of attractions. So for intermolecular forces of attraction is including van der Waals forces and hydrogen bonding. So intermolecular forces are attractive forces between the molecules. Okay, intermolecular forces responsible for the physical properties of the molecules. For example, the melting and boiling points. And intermolecular forces are much weaker than the intramolecular forces. Intramolecular forces are the covalent bonds, within the molecules. So inter is between the molecules. So between, and so inter is between molecules. Intra is within the molecules. So covalent bonds inside the molecules. Okay, so the physical properties of the covalent molecules are due to the intermolecular forces. So when you want to explain the melting point and boiling point, you have to use intermolecular forces for simple covalent molecules. Okay, generally there are different types of intermolecular forces. So we have lipo and induced lipo forces. So these two are referred to van der Waals forces. Okay, so generally we call them van der Waals forces. So van der Waals is a physicist, Dutch physicist, Johannes van der Waals. So when you write the name of the van der Waals, you have to be careful. So the V is a small letter and the W is a capital letter. Okay, so V is small letter, W capital letters. Okay, so let's then we have hydrogen bonding. So actually hydrogen bonding is a lipo process, but because it's a very strong and it only involves a certain elements, very electronegative elements. So we separate the hydrogen bonding from the lipo forces. Okay, so now let's look at van der Waals forces. So like I told you just now, van der Waals forces we have lipo forces. So it's permanent one, so we call it permanent. We also can call it permanent lipo forces. Then the induced lipo forces also can call as temporary induced lipo forces. Another name is London dispersion forces. So it's the same thing. So first let's look at permanent lipo forces. So permanent lipo forces only occur in the polar molecules. Okay, so it's a attractive forces between the polar molecules. So remember you have learned polar molecules during Shannon lessons. So polar molecules are not symmetrical, the shape, and they have a lipo moment. Okay, so for example, the hydrogen chloride. Okay, so these polar molecules, they are held together by permanent lipo forces, or you can say lipo forces in the liquid and solid state. So lipo forces are weaker than the covalent and the ionic bonds. The covalent bond is ionic bonds. So examples of lipo forces in the polar molecules is the hydrogen chloride and the liquid trichloromethane, CHCl3. Okay, so let's look at so you have to know how to draw the lipo forces. So example, we use hydrogen chloride. Okay, so hydrogen chloride, hydrogen is less electronegative than Cl. So hydrogen chloride will have a partially positive charge. Okay, then chlorine will have a partial negative. Okay, so you draw out the polar molecule. Okay, then normally you can roll 2 or 3, okay? So the best is roll 3, 3 or more, okay? So you roll 3 and more to show the forces. Okay, so they will arrange themselves so that positive is next to the negative, so they will attract to each other by the lipo forces. So you label the forces. So positive attract to the negative. Okay. So this is hydrogen chloride. Okay, so the strength of lipo attraction depends on the magnitude of lipo moment. So the higher the magnitude of lipo moment, the more polar the molecule and the stronger the permanent lipo attraction. So higher magnitude, more polar, so stronger permanent lipo forces. So example, you can look at this. So when the lipo moment increase, okay, so you can see the boiling point increases. So means the strength of the lipo forces increases. So you have to compare between the molecules with similar mass. Okay, so it's because of the lipo moment increase, so the boiling point increase. Okay, next we look at temporary induced lipo forces. Okay, so also can call as induced lipo forces or random dispersion force. So all atoms, including the polar molecule, all atoms, molecules, non-polar and polar molecules, they will experience induced lipo forces. So the induced lipo is because of the random movement of electrons. So the electrons always move okay, at the orbit. So at certain point, okay, at certain point, the electron the electron distribution is not equal. Is unequal means slightly displaced to one side of the atom or molecule. So now the molecule will have a dipole moment. Okay. So at certain point when the electron is placed to one side, so when this one partial contribution, so this one instantaneous dipole. So the electron gather at one side, okay. So one side of the atom or molecule have more electron, so it will have temporary dipole. So here more electron, so negative. So this atom or molecule has instantaneous dipole, that means temporary dipole. Okay. So when this molecule go near another molecule, okay, beside and its neighbor, so it will induce a dipole in the nearest neighbors atoms or molecule. Okay, so here positive, it will make this one negative. Okay, then this one will make this one positive. Okay, so here we'll have this neighbor atom will acquire a partial negative charge. Okay, then here this neighbor will acquire a partial positive. Okay, so we call this induced dipole. Okay, so it's because of the uneven distribution of electron density. Okay, so the strength of dispersion force increases as the number of electrons increases. Means you have more electrons when the electrons further. Okay, number of electrons further from the attraction of nucleus. The molecular size bigger, easier for the electron to be distributed. Okay. So bigger size, the electron further from nucleus, the more electron to displace to one side. So the van der Waals forces or induced dipole forces will stronger for the bigger size molecule because easier for the electron to distribute to one side, displace to one side. Okay, so more and more electrons to displace to one side. So you can see here, when the electron move to one side, it will become negative, partial negative here. Okay, so now we look at the factors affecting the strength of van der Waals forces. So here we have three factors. First is the molecular size, then second polarity of molecules, and third is a molecular shape. Okay, so we look at one by one. So molecular size, that just how I told you. Okay, so when the molecular size increase, the van der Waals forces also increase. So it increase with the van der Waals forces increase with the molecular size and or mass. So bigger molecule will have more electrons. So and the electrons further from nucleus, okay, further, so less tightly held by nucleus, so easier to disturb. So bigger molecules have, hence a bigger molecule has stronger forces. They hold them together, and hence the melting point and boiling points are higher. Okay, so we look at this table. So this is group 14 hydrides. So going down the group, the size increases. Size increases. So the boiling point increases. Okay. So because of the stronger van der Waals forces. Another one is group 17 elements. So when you're going down the group, the size increases. Okay. Size increases in this order, and the strength of molecular forces, intermolecular forces increase in the same order. So the melting point and boiling point also increase in the same order, going down the group. Okay, so far any questions from the students?
So far, they have no any question yet.
Okay, thank you, Cikgu Mama. So I
Okay.
continue with the third, and the second one, polarity of molecule. So when two molecules have, we compare molecule with similar molecular mass, so the strength of van der Waals forces increases with increasing polarity. So polarity increase when the molecule have large difference in the electronegativity. Okay, so it means the molecule will be more polar. So the lipo attraction, just now you learn, will be stronger. Okay, stronger attraction. So you can see here, lipo moment increase, the boiling point increase because of the lipo forces increase. Okay, then we look at the factors of molecular shape. So this is this factor more significant. Okay, you can see more clearly in the organic compounds with isomers. Means they have the same molecular mass and same functional group. Okay, but the structural isomer is different. Okay, so here is a structural isomer. So straight chain isomer or molecule have larger surface area than the branch chain molecules. Okay, so when you have larger surface area, so more contact, greater contact. So you can have more electrons move. Okay, displace more electrons displace at the molecules. Okay. Further listen here. Here means move more listens. So the strength of van der Waals forces increase. So you can see the example. Boiling points of 3 isomers of pentane. So they have the same mass. Okay, only the structural formula is different. So this is branch one. So this one straight chain. Okay, so straight chain you can see more surface area for the attraction of the induced lipo forces. This one is non-polar molecule. So they can form more van der Waals forces. Okay, then the branch one, the surface area is smaller, more spherical. The molecule is more spherical. So the surface area are smaller. So less van der Waals forces can be formed. So boiling point is lower compared to the straight chain. Okay, higher boiling point. Okay, so when we answer the question, first you have to see whether the molecules have same molecular size. Okay, so if the molecule size different, you can straight away use and also it's non-polar, non-polar and same different molecular size. Then you can discuss, for example, this one. Okay, So this one are non-polar. Then they have different molecular size, different relative molecular mass. Okay, so you can say that the larger molecule will have a stronger van der Waals forces. So it has larger one will have a higher melting point. Okay. Then if the molecular size are similar, comparable, so you see whether it's polar molecules. Okay. So normally for polar molecules, so the lipo interactions, so more polar molecules will have stronger van der Waals forces. For example, you see this one. So this one you can see got one molecule is polar molecules, and another one is non-polar. So you just compare the boiling point of the polar molecules will be higher, okay, because it has a stronger permanent lipo forces. Then the non-polar is a induced lipo forces that is weaker. Okay, so the permanent lipo forces is stronger than the induced lipo forces. Okay, any question from the students?
Not yet, Puan Lau. So far, they have not any question.
Okay. So I think we can rest for a while before I continue with hydrogen bonding.
Okay, Teacher Tang. Shall we take a break?
Thank you.
Sekejap. Okay, sebelum tu, cikgu nak umumkan 3 AYU code ya. Okay,
Next one, hydrogen bond.
A10. Okay, A10. Okay, Teacher Tang, boleh
Tuisyen
kita
online
berehat
percuma.
seketika?
Tuisyen online percuma. Layari www.academyyoutuber bagi mengikuti tuisyen online secara percuma. Prasekolah, sekolah rendah, sekolah menengah, semua ada di Akademi YouTuber. Rujuk jadual di laman sesawang www.academyyoutuber.com. Semoga masa terluang anak-anak anda diisi dengan sebaiknya. Tuisyen online percuma, mestilah Akademi YouTuber.
Okay, kita kembali. Okay, diserahkan kembali kepada Teacher Vivi Lau. Silakan.
Okay, thank you. So we continue with hydrogen bonding. Okay. So what is hydrogen bonds? So hydrogen bond is a special type of lipo forces. Because hydrogen bond occur in polar molecule also, but because of it's a very strong type of forces, and it's only specified in highly electronegative atom. Okay. So means fluorine, oxygen, and nitrogen. So it have a different category from the lipo forces. Okay, so for hydrogen bond to form, the hydrogen atom must bonded, okay, in the polar bond, must covalently bonded to a small and highly electronegative atom. So these three, fluorine, oxygen, and nitrogen. So you have to memorize. Okay. And then this hydrogen atom can form bond with another very electronegative, okay, another very electronegative atom with their lone pair electrons. So you can see here. Okay, so example is water. So the hydrogen bonded to the oxygen. Okay, oxygen very electronegative. Then this hydrogen atom will form hydrogen bonds with another oxygen atom. Okay, and the lone pair electrons. Okay, so when you roll the hydrogen bonds between the hydrogen atom here and the oxygen atom, neighbor water molecules. Okay, so in the covalent bond between hydrogen and X, X is a very electronegative atom. The electrons are drawn towards X. Okay, because this one is more electronegative, so the electron will go near the X. Okay, so means this hydrogen will have partial positive. Okay, so because the hydrogen has no inertial electron, so means the nucleus of the hydrogen is very close to the lone pair of another of this Y. Okay, so that's why the hydrogen bond is very strong, because the hydrogen is nucleus very close to the Y lone pair. So it's a very strong hydrogen bond. Okay. Okay, so the hydrogen bonds are strong. So the very electronegative atoms are usually fluorine, oxygen, and nitrogens. Okay, so hydrogen bonds are stronger than the van der Waals forces, but it's still weaker than normal covalent and ionic bonds, electrovalent bonds. Okay, then you have to know that a few examples. So example, we have water, hydrogen bond in water, hydrogen fluoride, and ammonia. Okay, so for water, each water molecule can form 2 hydrogen bonds. Each water molecules, okay, on average. This is because the water has 2 hydrogen atoms and 2 lone pair electrons. So the water on average can form 2 hydrogen bonds per molecule. Okay, so when you roll, you have to know how to roll the hydrogen bonds, like just now the hydrogen chloride, okay, the lipo forces. So the same thing, you label the oxygen delta negative, more electronegative one, delta negative, less electronegative hydrogen, delta positive, okay. So you label the partial negative, partial positive. So label the hydrogen bonds. So hydrogen bonds also dotted lines, like just now. Okay, then label the lone pair electrons. Okay, so must show the lone pair electrons. So you have to at least roll 3 water molecules when you roll the hydrogen bonds. Okay, better you roll 3. If you roll 2, like not enough. Okay, so water can form 2 hydrogen bonds per molecule on average. Okay, then we look at ammonia. Okay, so ammonia on average only can form only 1 hydrogen bonds. Okay, so you also have to know how to roll. So when you roll the hydrogen bonded, okay, hydrogen bond to the nitrogen atom with the lone pair electrons. So label the partial positive, partial negative, and label the hydrogen bonds, okay, with dotted lines, and label the roll the lone pair electrons. Okay, this one forgot to explain. So the water ammonia has only 1 lone pair electrons. That's why it can only form 1 hydrogen bonds per molecule, because it only has 1 lone pair electrons. Okay, then we look at hydrogen fluoride. Okay, so hydrogen fluoride, same like ammonia, also can only form 1 hydrogen bond per molecule. Okay, because hydrogen fluoride only have 1 hydrogen atoms. Okay, so the reason that 1 hydrogen atoms. So same thing when you want to roll the hydrogen bonding, label the hydrogen partial positive, fluorine partial negative, and label the hydrogen bonding. And roll the hydrogen bonds between hydrogen and fluorine, show the lone pair electrons. Okay, so here explanation for hydrogen fluoride. So hydrogen bond in hydrogen fluoride is stronger than the ammonia. Okay, so hydrogen fluoride, the fluorine is very electronegative. Okay, so when the hydrogen nucleus is partially exposed, so the hydrogen will go very near to the another fluorine atom, okay, of another hydrogen fluoride molecule, without being repelled by the electron cloud around the fluorine atoms. Okay, so although you can roll when you roll the hydrogen fluoride, you can roll 2, but on average, hydrogen fluoride only can form 1 hydrogen bond because only 1 hydrogen atoms. Okay, so now we compare the boiling point of the 3. Okay, so the boiling point of water is higher than hydrogen fluoride, and higher than ammonia. Okay, because strength of the hydrogen bonds of water is bigger than or stronger than hydrogen fluoride and ammonia. Okay, because that's how you have learned that water can form only 2 hydrogen bonds per molecule. Then hydrogen fluoride and ammonia only can form 1 hydrogen bond on average. Okay, so hydrogen fluoride is stronger than ammonia. Okay, because fluorine is more electronegative than the nitrogen atoms. Okay, so this one is you have to know. Okay. So any questions?
No, Teacher Vivi Lau. Not any
Okay, thank
question.
you. So we look at properties of hydrogen bonding. Okay, so just how we have learned the example of hydrogen bonds and how the hydrogen bond is formed. Now we look at the properties of hydrogen bonding. So solubility of some substances in water is because of hydrogen bonding. So you learn that normally covalent compound is insoluble in water, but for certain covalent molecules, they can dissolve in water. Okay, this is because they can form hydrogen bond. For example, the ammonia just now. Ammonia is very soluble in water because it can form hydrogen bonds with the water molecules. Okay, so you have to know how to roll the hydrogen bond between ammonia and water. Okay, so just like just now. So as usual, the molecules you must roll in the shape, okay, molecular shape. Pyramidal for ammonia, band shape for the water. Then you label the hydrogen bonding and label the partial negative, partial positive. Okay, so label, okay, and label the hydrogen bonding. Okay, so the hydrogen bonding in certain organic compound, okay, also is used to explain their solubility. Okay, so ethane that does not have electronegative atom, they cannot form hydrogen bond. Okay, so they cannot dissolve in water. But ethanol can, ethanol alcohol, a type of alcohol can dissolve in water due to the hydrogen bonding. And also we have carboxylic acid. It means sugars, carbohydrates. They also can form hydrogen bonding with the water molecules. So you must know how to roll also. So for example, ethanol is with the hydroxy bond. So the oxygen is bonded to hydrogen. So this hydrogen and oxygen, they can form hydrogen bond with water. So you just roll the hydrogen bonds. Okay. So label the partial positive, negative. So show the lone pair electrons. Okay. So another example is carboxylic acid. So this one is ethanol acid. So you just roll the hydrogen bonds between the hydrogen and oxygen of the water. Okay, so another properties of hydrogen bonding, okay, is to explain the high melting point, high boiling point in the substance that can form hydrogen bond. Okay. So molecular substances held together by hydrogen bonds have higher boiling point than molecules held together by van der Waals forces. Okay, because hydrogen bond is stronger than van der Waals forces. So example is in the hydrides of group 16 elements. So if you look at the graph, later we see the graph. So if you, based on the molecular mass for van der Waals forces, so if you're going down the group 16, so if molecular size increase, so means van der Waals forces increase the strength. So should be boiling point increase. So means water as the on top of the means water is smallest the size. So water should have lowest boiling point. Okay. So because of the water is smaller size, okay. So instead it will have higher boiling point. So it's because of the strong hydrogen bonds between the water molecules. So you look at the graph. So if you according to the molecular size for van der Waals forces, so water should be here. Water should be here means lower than the hydrogen sulfide because water is smaller size than the sulfur. Oxygen is smaller than sulfur, but water has higher boiling point than hydrogen sulfide. Okay, because it can form hydrogen bonds. So hydrogen sulfide and the others members of the group 16 highlights, they only can form van der Waals forces. So they will have lower boiling point than the water. Okay, same thing for the this one, hydrogen fluoride. Okay. Hydrogen fluoride smaller size than hydrogen chloride, so should be lower also. Should be here, okay, but it's higher because of hydrogen fluoride can form hydrogen bond also. The other cannot form it. Okay. So the boiling point of water is higher than the boiling point of hydrogen fluoride. Okay, although fluoride is more negative than oxygen, so this one explained just now. Water can form 2 hydrogen bonds per molecule. Then hydrogen fluoride only can form 1 hydrogen bond per molecule. Okay, then hydrogen bond also can be used to explain the alcohol with similar mass, okay, with the propane. So if you use van der Waals forces, ethanol should have okay, the ethanol has higher boiling point because of the strong hydrogen bond. If similar mass, they should have similar van der Waals forces strength. So it's higher boiling point, so means it has another force hydrogen bonds. Okay, then we look at the anomalous, another properties anomalous relative molecular mass of certain organic compounds, ethanoic acid. So ethanoic acids should be, if you follow the molecular formula, should be 60 the relative molecular mass. But when we take a look, you will get relative molecular mass larger, okay, larger the 60. So this is because of the hydrogen bond also, because ethanoic acid can form dimer, okay, they can form dimer by hydrogen bonds, okay. So the process is called dimerization. So you must know how to roll the hydrogen bond also. So you have to arrange ethanoic acid in this structure, trigonal planar. Okay, the carbon has 3 electron pairs, so trigonal planar. So then you form the oxygen, form the hydrogen bond with the neighboring hydrogen. Okay, so you show the hydrogen bonds, so they can form 2 here. That's why the mass of the ethanoic acid is not 60 but 120. They form a dimer. Okay, then another example is a hydrogen fluoride. Okay, so hydrogen fluoride also has larger molecular mass than expected, okay, because they can form trimer, okay, trimer or limer, sometimes limer, okay, so by hydrogen bonding, okay, so you also roll like this, okay. Okay, another properties is a explanation of why the density of solid water, solid ice is lower than the liquid, okay. So normally solid will have higher density than the liquid, because solid the molecules are more compact, so smaller volume, right? So should be density of the solid higher, okay. Density is the mass over volume, okay. So should be solid have smaller volume, okay, because the molecules more costly big. But for ice, okay, solid water uh, is different, different from the normal. That's why we say anomalous. So it's lower density. Okay, so because of that, ice can float on the water. Okay, so the explanation is because ice has a hydrogen bonds. Okay, so they has hydrogen bonds in the between the molecules. So the ice will arrange in tetrahedral arrangement. Okay, so because of the tetrahedral arrangements, the water molecules are not closely packed together. So it has a lot of empty spaces. Okay, so it will have lower density than the liquid. Okay, so ice has lower density than the liquid. So this is unusual. So for the normally the solid will have higher density than the liquid. Okay, so you can see the tetrahedral arrangement. Okay, so the water. So we look at this one. Okay, so the water has the ice. Okay, so the each water is tetrahedrally bonded to the another four, one, two, three. Let's say this one, another four water molecules. So a big empty spaces are formed. So when you heat the ice, it will melt. So the ice hydrogen bonding is broken. So the liquid is closer, okay, to each other. So the tetrahedral arrangement is broken when you melt the ice. Okay, so the water will be more costly packed compared to the ice. Okay, so hence water has a higher density than the ice. So that's why ice will float on the water. Okay, so now we look at question number 1. So students can try to answer the question and write in the chat box.
Okay, student, you can
Which
try.
one?
You can try to put A, B, C, or D at the chat room.
So I read the question. Which of the following sets are arranged in the order of increasing boiling point? Increasing boiling points. So these are all simple covalent molecules. So you have to use intermolecular forces and not the intramolecular forces.
Okay, student, you can try to participate. Okay, since this topic is very important, even for term 1, term 2 or term 3.
So far you have learned 2 types of van der Waals and hydrogen bond. So the A, B, C, D, they are all same
Okay, only
only different arrangement.
answer. Only Zinchai answer B.
Or B, yeah. Okay, any other answer?
Oh, not yet.
Oh, yeah. Okay, so very good. So the answer is B. Okay, so we see B. So B we have CH4 is non-polar. Okay, then NH3, HF, H2O, they are all polar molecules. And they have very electronegative atom. Electronegative atom. Nitrogen, fluorine, and oxygen. Okay, so this one non-polar is this one is a van der Waals forces. Van der Waals and is induced. Induced lipo. Okay, so it's induced lipo only. Then this one have hydrogen bonding because they have nitrogen, fluorine, oxygen. Okay, then you have learned just now water can form two hydrogen bonds. Water form two hydrogen bonds. Then hydrogen fluoride, the fluorine is more electronegative than nitrogen. Okay, so that's why water has strongest hydrogen bonds. So highest melting point. Followed by hydrogen fluoride. Okay, hydrogen fluoride is strong. Hydrogen bond is stronger than ammonia because hydrogen fluoride, the fluorine atom is more electronegative than the nitrogens. Okay, so methane is a weakest. Okay, because methane is non-polar, so only have weak van der Waals forces. And is the induced lipo one. Okay, so very good, Zixing. Okay, then we look at next question. So which of the following statements is incorrect?
The
So I
student
read
try
the
to
question.
answer
Okay, so first statement.
question 2.
Okay, so first statement, lipo forces act between non-polar covalent molecules. Second, water has higher boiling point due to the presence of intermolecular hydrogen bonds. Then C, the larger the molecular size, the greater the van der Waals forces. Then last one, polar compounds have higher boiling points than non-polar compounds of similar molecular mass due to the existence of lipo attractions. Okay, so which is a incorrect statement. So be careful, incorrect. Okay, any answer?
Okay, not yet. Belum lagi. Okay, student boleh cuba ya. Boleh cuba jawab soalan. Okay, just careful for the term of incorrect, the incorrect statement. Maybe
Your answer?
you can continue, Teacher Vivi Lau.
Can continue.
Still too shy to answer.
Okay. So actually this one is the last question. So want to wait for
Zincha
to see
again.
your answer.
So I answer A.
Okay, very good. So A is the answer. So this one is incorrect, because lipo is permanent one. Lipo first source is permanent one, so it's only in the polar. So this is wrong. Should be polar molecules. Okay, so this is wrong. So this is the answer. Okay, A is answer. So second is correct. Okay, so water has high boiling point due to the presence of intermolecular hydrogen bonds. Correct. Then van der Waals forces, one of the factor is because of the size. So larger size have stronger, greater van der Waals forces. Then polar compounds will have high boiling points, because the lipo forces is stronger than the induced lipo, or temporary lipo-induced lipo forces. Non-polar only can have temporary lipo-induced lipo. Okay, so permanent one is stronger than the induced one, because they want temporary. So when the electrons move again, the forces will disappear. Okay, so B, C, D is correct. So A is wrong. So that's all for my lesson today. Thank you very much for being with me today. Okay.
Okay, so kita habis awal hari ni ya. Okay, nampaknya kita habis awal hari ni. Okay, terima kasih diucapkan kepada Teacher Vivi Lau atas perkongsian ilmu yang sangat bermanfaat. Okay, Alhamdulillah dan sudah selesai kelas kita. Kita nak diucapkan juga kepada semua yang setia mengikuti kelas kita pada petang ini dari awal hingga ke saat ini, dan juga pada student who taking part in answering question, Zin Chai. Okay, hopefully our next class lebih ramai pelajar akan turut serta, lebih bersemangat untuk mengikuti kelas kimia kita pada minggu-minggu akan datang. Sebelum kita tamatkan sesi siaran langsung, mohon tutup ruangan chat, klik butang subscribe yang masih merah dan aktifkan ikon loceng supaya para pelajar tidak terlepas sesi kelas yang seterusnya. Sekiranya suka apa yang dipelajari, sila klik like and share kepada rakan-rakan. Dan seterusnya sila type and then sebelum tu cikgu nak beri AYU code yang seterusnya, iaitu 588. Our next AYU code is 588. Sekali lagi cikgu ucapkan ribuan terima kasih kepada Teacher Vivi Lau atas kelas petang ini. Begitu juga dengan Teacher Tang dan tadi Cikgu Syanon. Dan jangan lupa untuk dapatkan jadual tuition online terkini melalui portal www.academyyoutuber.com serta dapatkan juga info terkini bagi bantu cikgu untuk sebarluaskan kelas tuition percuma ini kepada rakan-rakan dan guru-guru seluruh Malaysia. Semoga kita mendapat manfaat daripada kelas-kelas yang akan dijalankan. Ingat hashtag bermula percuma selamanya percuma, insyaAllah. Terima kasih kepada semua. Segala yang baik datangnya daripada Allah. Jika terdapat sebarang kekurangan dan kelemahan adalah daripada kami sendiri. Kelas tuition online percuma berakhir. Sudah. Terima kasih. Berjumpa lagi kita di lain siaran.
Wow,
bye-bye semua.
Banyaknya hadiah menarik menanti anda.
Wah, kini Akademi YouTuber mengambil inisiatif baru di mana memberikan hadiah-hadiah ini secara percuma. Ya, percuma kepada anda semua. Bagaimana caranya? Dengan mengikuti kelas tuition online percuma Akademi YouTuber sambil mengutip mata kredit, anda dapat menukarkannya dengan hadiah-hadiah yang menarik ini. Tunggu apa lagi? Segalanya percuma.
Jangan lepaskan peluang tau. Dah dapat banyak hadiah menarik, takkan nak lepaskan peluang.
Layari www.academyyoutuber.com sekarang untuk maklumat lanjut.
Dibawakan kepada anda oleh Akademi YouTuber.